Hi, our medical device is the SmartPlate, and together we are a four-person team including William Pavia, David Jang, myself, Dylan Blair, and Jesse Nelson, and we are Team 959 of this competition. The SmartPlate is used in conjunction with the A-Plate or the quad plate made by Orthofix, or more importantly, Dr. Peter Stevens. So what is the A-Plate? It's a guided growth system that basically it is inserted into a convex side of a child with an angular deformity, such as, say, knock knees or bow-leggedness. And what this does is it stunts the growth on the convex side and allows the defected side to catch up. And then once the defected side is caught up, the device can then be removed, and the child can then go on with their lives once their angular deformity is fixed. So the problem or pain point with this current device is that methods of measuring progress while using guided bone growth systems require the patient to return to the hospital and receive x-rays, which can both be inconvenient for the patient and expensive and makes more frequent measurements less feasible. So our SmartPlate device is a handheld device that we have a sensor on this outside, and then the sensor moves along this opening, and what this does is it measures the movement of the screws as the screws diverge. And then with all this data is then exported to a physician GUI, and then the physician can then track the real-time measurement of the growth of the bone.
So as far as our business strategy, there's about 1,000 to 2,000 guided growth procedures a year. And there's currently no products that actually measure the movement of these growths. They do it with only x-rays. As far as our distribution strategy, we're going to use a specialized distributor where we will pair up our device with somebody that sells the current 8-plate already, since they already have that relationship with the stakeholders. And the progress of this procedure is typically monitored for about 12 to 18 months, and they receive around 6 x-rays. The cost of a single x-ray is between $200 and $500. So the total cost of this treatment is $1,500 to over $3,000. The cost of our product would be $800, which leads to a savings between $7,000 and over $2,000. Our device will be a Class 2 device under this regulation number, and we'll be able to go through the FDA pathway with a 510(k) pre-market notification. There's currently no CPT reimbursement codes, so until we are able to apply and get approved for that, we'll use a Category 3 for procedures until CMS is able to approve us.
Okay, so here's an exploitive view of our device, and so when we actually collapse this view, you see that we have a servo motor that attaches to a rack and pinion gear, and this is all powered by an Arduino Uno, so that when it's all enclosed, the servo motor can then power this plate to slide where the sensor is attached at that little opening. And so the idea is that we take 2 magnets, we place it into the screws, and then the distal end of the screws are then tracked, or the distal end of the magnets are then tracked with the sensors so that we can actually measure the distance between the magnetic fluxes and then approximate the distance between these screws as they diverge, and furthermore approximate the growth of the throughout the procedure. And then once it's actually powered, you see how the rack and pinion gear slides across. That was, as I mentioned, powered by the Arduino Uno. And so then a brief demo of how this device is actually used is that the patient or caregiver will take the handheld device and they'll hold it up to their leg. When they hold it up to their leg, they will then power on the device so that the sensor slides along, and then we'll actually measure the distance between these magnets, or the distance between the screws. The data is then processed to approximate the distance between them. It is then sent to the physician so that the physician can load the data into their GUI or their app, and then they are able to see a real-time timestamp the distance between the measurements, as well as the growth that has occurred between the last measurement as well as the overall procedure.